Today, I want to start off by doing a quick review on the types of angles that we have covered so far. The first one I'm going to talk about is the acute angle. The acute angle is one that measures less than 90 degrees. Imagine pinching your fingers together just a little bit, creating a small wedge shape. Or picture the corner of a slice of pizza that's been cut into 8 pieces. That's an acute angle. The next one we're going to just review quickly is the right angle. A right angle measures exactly 90 degrees. Think of the corner of a piece of paper or the corner where 2 walls meet. It forms a perfect L shape. When you see the little square symbol in the corner of an angle, like this one right here, that tells you it's a right angle. The third one is the obtuse angle, and it measures more than 90 degrees, but less than 180 degrees. Picture opening a book about halfway. The angle between the covers would be obtuse. It's wider than a right angle, but not flat. The next is a straight angle. A straight angle measures exactly 180 degrees. Think of a straight line when you make a mark on a line and measure the angle on either side. That's a straight angle. It looks like a flat line with no bend at all. As for the reflex angle, that measures more than 180 degrees, but less than 360 degrees. Imagine a pizza with just one slice taken out. The remaining pieces form a reflex angle. It's like a wide mouth that's almost made a complete circle. As for the full angle, well, it measures exactly 360 degrees. Picture spinning around one complete time. You've just traced out a full angle. It makes a complete circle, starting and ending at the same point. We're going to start with this angle right here. When you look at it, you may be able to think you know right off what it is, and you might be right. This is a right angle. A right angle, once again, measures exactly 90 degrees. Now, sometimes you might think it's a right angle, but you want to use the protractor to be absolutely sure. To use the protractor, you want to line up the vertex with the little bubble circle in the middle of the protractor. You want to make sure that the bottom arm of the angle is lined up with the 0 line on the protractor. Now you can measure it, and you can see by looking straight up as I have it in place that this angle is exactly 90 degrees, which of course is a right angle. This next one over here might look a little different, and these may not be the angles you're used to seeing all the time. This one is called a reflex angle. A reflex angle is one that is more than 180 degrees, but less than 360 degrees, or full rotation. And you can see the angle is quite large, but it does not make a full rotation. To find out how many degrees the reflex angle is, I need to find the interior angle. So the part that is not filled in, and I'm going to use my protractor to do so. I'm going to line the vertex up right in the middle bubble of the protractor. I'm going to make sure that the bottom arm of the angle is right on the 0 line, and I can see that this is exactly 30 degrees. Now that 30 degrees is my interior angle, not the reflex angle. I need to use this information to solve to find out how many degrees the reflex angle actually is. I know that a full rotation is 360 degrees. I'm going to subtract the interior angle, which is 30 degrees, to find out how many degrees my reflex angle actually is. 0 subtract 0 is 0. 6 subtract 3 is 3. And 3 subtract nothing is 3. I'm going to include my degree sign. I have just determined that the reflex angle is 330 degrees. The next angle I'm going to look at is this one. I can tell just by looking at this angle that it is an acute angle. Acute angle. I know that because it is less than 90 degrees. But to know exactly how many degrees, I need to use my protractor. Lining it up once again with the vertex and the bottom line of, or the bottom arm of the angle. And this is right there. It is exactly 45 degrees. And if I'm wondering, well, does that fit with an acute angle? Yes, absolutely it does. An acute angle is an angle that is less than 90 degrees. And 45 degrees is definitely less than 90 degrees. Coming over to the next angle, this is also a reflex angle. I'm going to write the name right beside it. It's important that you get comfortable identifying what angles you are measuring. This reflex angle, it's really important to know because I need to do an extra step to find out how many degrees the reflex angle actually is. To begin, just like I did on the one above, I use my protractor to measure the interior angle. This part right here. Once I have my protractor lined up, I can see that this interior angle is 105 degrees. Great, but I still haven't solved for what my reflex angle is. To do that, I need to start with 360 degrees, the amount of a full rotation. I'm going to subtract the 105 degrees to know how many degrees are actually in my reflex angle. I am going to need to regroup. I'm going to regroup a 10 from there and bring it over here. 10 subtract 5 is 5. 5 subtract 0 is 5. And 3 subtract 1 is 2. Put my degree symbol. So this reflex angle, I have solved it, that it is 255 degrees. That does suit the definition because a reflex angle by definition is greater than 180 degrees, but less than 360 degrees. We have 2 more examples on this page. This is another reflex angle. To make sure that everyone is comfortable solving for a reflex angle, it is important to do lots of examples. So for this particular angle, once again, I do need to solve for the interior angle first. Using my protractor, lining the middle circle up with the vertex and the baseline of the protractor at 0 with the bottom arm of the angle, I am able to see that the interior angle on this angle is 60 degrees. Not quite done. I need to then write 360 degrees, the amount of a full rotation, and subtract the interior angle, which was 60 degrees, to find out how many degrees my reflex angle actually is. And by doing that, I discover that my reflex angle is 300 degrees. One more reflex angle to go. Here, once again, I'm going to label this as a reflex angle. I can tell that it's a reflex angle by looking at it because I see how large the angle is. I can already tell it's more than 180 degrees, but it is not a full rotation. Using my protractor, I'm going to line it up with the vertex and the bottom arm of the angle. Make sure it's right at 0 to have an accurate measurement. Then I can see this interior angle is exactly 135 degrees. That's the interior. So once again, I need to subtract. I start with a full rotation, 360 degrees. Then I'm going to subtract 135 degrees to find out how many degrees my reflex angle is. Doing that, I need to regroup. 10 subtract 5 is 5. 5 subtract 3 is 2. And 5 subtract 1 is 4. Oh, sorry. My mistake there. Not 5. That was over here. This is still a 3. 3 subtract 1 is 2. So 225 degrees is what my reflex angle will be. To make sure, if you're ever unsure that your angle is correct when you subtract, you could always add the interior angle to the reflex angle, and you would want those to equal 360 degrees. All right, on to the next set of questions. I've started here by asking, do the angles in each set have the same measure? So let's take a look at the number 2A angles. Here we have this angle and this angle. I can see by looking at this one that this is an obtuse angle. And I like to be in the habit of labeling what type of angle I'm dealing with to know if my answer makes sense when I use my protractor. So using my protractor and lining it up with the vertex, I can see, and take your time in measuring so that you get an accurate number. This angle is 105 degrees. And that does fit an obtuse angle, which by definition is greater than 90 degrees, but less than 180 degrees. So this angle is 105 degrees. I am going to turn my sheet a little here to measure this next angle. Using my protractor, once again, I line up that middle circle bubble in the middle of the protractor and the base arm line with 0 on the protractor to get an accurate measurement. And I can see this one, just like the other one, is 105 degrees exactly. So to answer the question, if these angles have the same measure, absolutely, they're both 105 degrees. I like to show this problem because I want everyone to be aware it doesn't matter what orientation the angle is. If it's sideways, if it's upside down, you are still measuring what this angle is. And in this case, they are both 105 degrees. Let's look at the next example. In these two angles, they look similar. The only way to know for sure is to use my protractor and measure them. But before I do that, looking at these angles, I want to label what type of angles they are. I can see that they are both acute angles and ones that measure less than 90 degrees. To find out how many, my protractor will help me out. As long as I line it up perfectly with the vertex and the bottom arm line. Here, this is measuring 15 degrees. I'm going to note that on my paper so that when I come to the next angle, I won't forget. And I'm going to measure this next angle, just turning my paper to make it a little bit easier to do. And lining it up, I can see this angle is also 15 degrees. Noting that it is 15 degrees, those two angles do have the same measure. They are both acute, and they both measure to have an angle of 15 degrees. I just want to go over a few more examples of measuring angles using the protractor. For these angles, starting with this one right here, I can see that this is an acute angle. Continuing to label what type of angles these are as I work through them also helps me learn how to spell accurately how these angles should be spelled. The next thing, using the protractor, lining it up with the vertex, making sure I take my time so that I get an accurate measurement. This angle is measuring 75 degrees. And I know an acute angle is an angle that is less than 90 degrees, and this one definitely is. Coming over to this, which is also an acute angle, lining up with the vertex and the bottom arm of this angle, making sure it is precise. There I have a measurement of 45 degrees. It's also important to note that these two angles, although they're both acute, their measurements are quite different. And the only way to have a clear idea and an accurate number is to measure with the protractor. It's helpful, though, to think about and remember what these angles look like as a 45-degree angle and a 75-degree angle in case you were asked to draw one using only a ruler and not a protractor to estimate to see how accurately you could draw these. The bottom angle here is what we call a straight angle. And in this case, we want to make sure we use the correct homophone for straight. This is a straight angle. I know by definition, the straight angle measures exactly 180 degrees, but it's very helpful to measure it on the protractor. Lining up the vertex and the baseline of my protractor with the bottom arm of the angle, I can see that this is exactly 180 degrees. There are a couple more problems on the other side of this sheet. The first one is an obtuse angle that is more than 90 degrees, but less than 180. And I do need to use my protractor and be very careful on an obtuse angle that you line it up, as always, with the vertex and the bottom arm of the angle at 0. When I do that, I can see that this angle is measuring 165 degrees. The next one is also an obtuse angle, but I can tell it's going to have a different measurement for the number of degrees. I'm going to line it up with the baseline and the vertex. And here I have an angle that is 105 degrees. And as always, I like to label them. This is an obtuse angle.